For the telescoping series, we're going to take a look at what it means to be a telescoping series first. So this is a special type of series and the last one that we're going to explore. So here, when we initially take a look at this, it should look vaguely familiar to you guys as something that is factorable on the bottom. So if I were to rewrite this expression, I would have 1 over n plus 2 over n plus 1. Now, in order to see the telescoping aspect of this series and what it means to be telescoping, what we're going to do is apply partial fraction decomposition to split this fraction that right now is a single fraction into two fractions. So a over n plus 2 plus b over n plus 1. Now we're going to say that this fraction is supposed to be equal to 1 over n plus 2, n plus 1. So if you remember from the previous chapter, in order to do this, we're going to go through the process and ask ourselves what we would have to do in order to find a common denominator between these two fractions. That would involve taking a multiplying by n plus 1, taking b times n plus 2, setting that all equal to 1. Now, we're going to let the value of n be equal to certain values to eliminate the coefficient so we can solve for the other one. So letting n be equal to -1 is going to eliminate this term and then leave us with 1b. If I plug -1 into here, I get 1b is equal to 1. So therefore b is equal to 1. Now if we do the same thing and let n be equal to -2, that's going to leave us with 1 equals -a, or a is -1. And again, that's going to allow us to eliminate this value here. So once we get all of that done, what we're going to do is plug that back in and then just say that the series can also be rewritten as 1 over n plus 1 minus 1 over n plus 2. And so the significance of this is now if I were to expand out and take 1, plug it into here, and then successively plug in the next index value of 2, of 3, I would get 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5 and then plus 1/5 ... until we get to the very last term, which should be 1 over n plus 2. Now the reason why we call this a telescope is if you think about a telescope, it's a telescoping series, but a telescope, the lenses collapse upon each other. So if you take a look at the terms, something neat happens here. So you'll notice that the -1/3 and 1/3, in theory, this negates each other. In theory, -1/4 and 1/4 will collapse upon each other. And same thing goes for the next terms up until the last term of 1 over n plus 2. So if I had a telescoping series where that occurred, then the limit as n goes to infinity is going to become 1/2 minus 1 over n plus 2, meaning that the first term is going to stay, the middle terms collapse upon each other and they cancel out, and you're left with this 1 over n plus 2 as your last term. So as we explore what happens as we keep adding more terms, we're going out to infinity, there's an infinite number of terms. Then as n goes to infinity, this last term, we're going to think about this as a limit. This is going to go to 0, and what we're left with is just the single first term left. So as the terms continually collapse, the last term, and the terms keep getting smaller and smaller, the last term is going to end up approaching 0, and we're left with just the first term. So in your notes, go ahead and put first term here. So you're left with 1/2 is your answer, which it happens to be the first term. So in general, all the terms between the first and the last cancel out, and you're left with just the first term for a telescoping series.